challenge of using graphs. Understanding part can be done by our LLM. Keerti, Purswani and Amit Kumar, they both are married. The different nodes and the relationships. Here you can see all the nodes that I have. There is one relationship of alumnus, then co-founder. These are the relationships. You can write your queries over here as well. This is where GraphRAG comes into picture. Graphs have been around for a really long time. But what changed since LLMs came into picture? How do LLMs impact knowledge graphs? What are knowledge graphs? And there's one very famous application of knowledge graphs called GraphRAGs. Why are the topics knowledge graphs and GraphRAGs trending right now, and currently why are they so relevant? We are going to be talking about all of this in this video with a lot of examples and hands-on coding. I hope you're excited. But before we begin, just a quick reminder to please leave a like and a comment. It would mean so much to me. Help me reach 1 million subscribers. I really think I deserve it. Let's begin. Let's begin by taking a lot of real-world use cases where using graphs just makes sense. For example, social media. Finding friends of friends would be so easy if we could just visualize the data on a graph. Similarly, if for LinkedIn I had to find first level of connections or second level of connections or third level of connections, finding this level of connections becomes very easy if I could just traverse on a graph. Similarly, suppose I have an e-commerce platform like Amazon. Now I have a lot of products, a lot of orders. How do I spot patterns? For example, just by visualizing the graph, if I can just understand that these products are usually bought together, then it would be really easy to recommend the products, right? So not just for Amazon, for any recommendation engine, maybe for Netflix or for Spotify, spotting patterns really helps. Like for Netflix, suppose I'm able to spot patterns like these movies are usually watched together. What is the common factors? Maybe the actors who have acted in, maybe the directors, maybe the genre. So like this, I will be able to spot the patterns. Versus if I have the same data available in some other kind of database, then I would have to run a lot of complex queries. Or if I had it on SQL, I would have to run a lot of joins. It becomes very complex, right? Versus on a graph, it becomes so easy to visualize the data, especially when the data is really complex. And for most of the real world use cases, we know that the data is going to be really complex, right? So spotting patterns becomes very easy. And not just for the recommendation engines. Let's take another example. Fraud detection becomes very easy because we are able to visualize the data. Suppose there's a lot of hopping happening from one account to another account to another account to another account. I will understand that, okay, money laundering is happening. There's some fraud happening over here. Or if I have a lot of patterns and then there is some outliers over there, then maybe these outliers are like frauds that are happening. Like this, I'll be able to see. Or similarly, suppose if I have to find routes or paths for traveling from one place to another place. What do we use? Google Maps. Internally, what it is just graphs. So we know that there are a lot of use cases, especially in real world, when we have a lot of complex data where graphs will be really useful. And graphs have been used since a very long time. But what is the challenge in using graphs? See, just think about it. For web series like Game of Thrones or Dark, a lot of graphs became famous that you can see this graph and you can understand that these are the characters and this is how they are related. But in order to be able to create that graph, a lot of domain knowledge is required, right? Like you need to understand that these were the characters, this is how they were related. You need to watch the entire series to be able to create the graph out of it. Similarly, suppose you were creating a graph to understand, okay, these are the movies. You maybe need to plot that these are the actors who have acted in, these are the directors who directed the movies. You need the domain knowledge to be able to create the graph. Similarly, while creating Google Maps, a lot of knowledge was needed, right? That, okay, these are the different entities, this is how they're related, or these are the different paths between these entities. So you need a lot of domain knowledge to be able to create the graphs. I hope that point is clear. Before we move ahead, I would just like to take a minute over here to tell you how you can learn live with me at Educosys. At Educosys, we have various courses. For interview prep, I have high-level system design, low-level system design, DSA. For project-based learning, if you want to create really interesting, scalable projects, not simple clone ones, check out HHLD. It is MERN plus DevOps plus HLD. We have hands-on generative AI course where I have not just covered the application side, but also the internals of LLMs in a lot of detail with white paper discussions, transformer architecture, and so much more. 10 hands-on projects have been covered over there. Please check out the curriculum, the testimonials, the LinkedIn profiles of all our students is tagged. Plus, if you enroll for any of our courses, you get lifetime access to all the batches, the past batches, the future batches. So you will get access to the Zoom recordings of the live class. So you actually get a feeling that it is live itself. This is the feedback that I have gotten from all our students, that it really feels like it is live only, even if it is not live. But if you want to attend live only, you will get access to all our future batches as well. So at least check it out. I would love to be part of your further learning journey. And if you still have any questions, feel free to reach out to us at support@educosys.com or just drop a WhatsApp or call us at this number. And now let's continue. This is where LLMs can be really helpful. We have a lot of LLMs, right? Like GPT, Gemini, DeepSeek. They are very efficient at what? At natural language processing. Now, suppose we take any LLM and we feed our entire book of Game of Thrones, basically the entire script of Game of Thrones, or suppose dark web series, any series. The point is that LLM will be very efficient in finding the entities and the relationships. So entities, by the way, to be clear, can be, so basically I'm talking about the nodes, which are the entities, okay? It can be anything. It can be person, place, thing, it can be anything. So it will be able to tell that these were the different characters. This is where they were supposed born, or this is where they lived at, or they were emperor of this particular location, or something like that, right? So LLMs will be very nicely be able to tell that, okay, these are the entities and these are the relationships between the entities. And so creating the graph becomes very easy, because that domain knowledge, the understanding part, can be done by our LLM. Let's do a quick short recap. We started by understanding that graphs are really useful in a lot of real world complex use cases. Then we talked about the challenge of using graphs. We need a lot of domain knowledge in order to be able to construct the graphs. We need to understand that these will be the nodes of the entities and these will be the relationships or the connections between these nodes of the entities. So that is the challenge of using graphs. Third, we understood that how LLMs can help us create the graphs, because LLMs are really good at natural language processing. So if we just give in that this is the document or this is the entire text, LLM will be able to identify and tell us that these are the nodes, these are the relationships, and this is how the graph can be created. And now let's talk about the challenge of using LLM to create graph. See, in order to be able to create our graphs, we want two things. We want the list of nodes or entities, and secondly, we want the list of edges or connections or relationships. See, nodes or entities mean the same thing, edges, connections, relationships mean the same thing. In order to keep things simple, I'm just going to use the terms nodes and edges. These are the usual terms, so just to keep things simple, let's use the terms nodes and edges only for now. So in order to be able to create the graph, I just want two things, list of the nodes and the list of the edges, and then I will be able to create the graph and visualize it nicely, right? But the problem over here is that we have to tell our LLM in the prompt that listen, I want these two lists. LLM is good at what? LLM is good at natural language processing. It is going to respond to us in natural language. So maybe in the starting it is going to say, here are your two lists. Maybe that is not going to be there. It is just going to say list 1, list 2. Maybe it is going to name the list properly. Nodes list, edges list. Maybe it's just going to say nodes, edges. See, you understand the fact that LLMs can be unpredictable. Think about using ChatGPT. It doesn't always respond in a particular way, right? The better your prompt will be, the better the response is going to be. That is definitely there. So maybe I can say in the prompt that don't respond with anything else, just give me the list, put nodes and then colon and then this, put edges and then colon and then the list. I can give a huge prompt like this. So this is one way. But the better way is that the good thing now is that most LLMs have a support of structured format. Let me just repeat that. So in our LLMs, there is a support of structured format. Most of the LLMs have it now, that we will say that this is the format in which I want the response. So I want two lists. One list is going to be of the nodes, one list is going to be the edges, and this is how I want the response. So LLM will make sure that I respond like this only. So most of the LLMs have this support, not all the LLMs. So one way is that we choose to write code for all of this, that we can see if our LLM has a support for structured format, then I'm going to use the structured format way. If that support is not there, then I can go ahead with the prompt way, or maybe I just want to go ahead with the prompt way, so I can write code for all of this. The point is that I can write code to use LLM to be able to create graphs. So this is one way that I write code for all of this. or I can use a framework where internally all of this is going to be happening. Okay, if you're not aware of the frameworks, let me just quickly tell you. If you're not aware, by the way, please check out LangChain LangGraph videos. These are really helpful and I highly recommend you to watch these. So basically there are frameworks available to be able to build agentic apps. Okay, there are a lot of benefits of using these frameworks. Let me just give you some quick examples. For example, if you are using GPT right now and you want to switch to say Gemini or DeepSeek, it is very easy. There's just one configuration and you will be able to switch between your models. Plus there's a lot of extra support like for tools, memory, like to be able to create graphs, right? So all of this code is already written. So it is very easy to use these frameworks. The most common framework is LangChain LangGraph. Other than that, you can also use Google ATK, but we'll be using LangChain LangGraph only. So LangChain LangGraph has the support of something called LLMGraphTransformer, where internally this is what is happening. So let me just repeat that. We are going to be using framework called LangChain LangGraph and we are going to be using LLMGraphTransformer. Internally what is happening, behind the scenes what is happening in LLMGraphTransformer, that either it is going to check that for the LLM that we are using, is there a support of structured format? So it is just going to use the structured format and we are going to get the response if these are the nodes, these are the edges. Or if that is not there, then it is going to send the prompt that this is how I want the response and then it is going to extract. But we don't have to explicitly write the code for that because we are going to be using the frame. So let's check the documentation of LLMGraphTransformer. This is the documentation that we are going to be following, how to construct knowledge graphs. So at a high level, there are going to be majorly two steps. The first one is extracting structured information from text. We are going to pass in simple text and then we are going to use the model to extract structured graph information. Basically, these are the nodes, these are the edges. Our model will extract it out and give it to us. The second part is going to be storing our graph into a GraphDB. So one of the most famous graph databases is Neo4j GraphDB, and this is also the one that I demoed in my all the HLD batches. So when I teach HLD at Educosys, I basically demo Neo4j only. This is one of the most famous graph databases. I demoed it in batch 1, batch 2, batch 3, and all the batches I've used Neo4j itself. So let's get started by first installing all the packages, and we will also need the OpenAI API key, and I'm going to be loading that from our environment variable. So I'm just also installing python.env. Let's just install all the packages and then let's load our environment variables. And we have loaded our API key from our environment variables as well. So setting up the Neo4j part we are going to do later. Let's for now focus on our LLMGraphTransformer. For LLMGraphTransformer, the first thing that we obviously need to do is to create the LLM object, and once we have done that, that is all that we have to do, pass our LLM to our LLMGraphTransformer. It is as easy as that. So internally the framework takes care of creating the graph transformer completely for us, and I have already set up API key, so this is all that I have to do. Let's just run this. I've already imported OS, so I didn't need this again. I can also remove it or let it be there, but I'm just removing it. I'm running it again. So I have the LLM transformer ready. And now we can take any document and I can convert that to graph documents. So it is so simple. LLMTransformer.a convert to graph documents, and as you can see, this is a convert is basically asynchronous. You could also use synchronous, which would be convert to graph documents, but here you will be able to convert the documents asynchronously and in parallel. So I'm just copying this and I'm going to just put it over here. But instead of using the text that they have used, let's do something interesting. I have written some text that is basically information about me and Amit. So I'm just going to copy that and put it over here. And we are going to try creating a graph from that. So let me just run this. It's taking some time to convert the documents. And here you can see the different nodes and the relationships, right? So this is what is there in the graph documents. You can see there are nodes and there are relationships, or you can say these are the edges, right? So what are the nodes? Keerti Purswani is a person, Amit Kumar is a person, so person is the type of the node. Similarly, Educosys, the type is company. Agentstop.ai, the type is company, right? Or NIT Calicut, that is where I have studied, so that is of the type institution, right? Tally Solutions, that is where I have worked, so that is again of the type company. Then Unanimous Solutions, this was the startup that I worked at. Similarly, there is Atlassian, it is company, right? Adobe, it is company. That is where Amit worked. Philips, Amit has worked at Philips. Oracle, these are the different companies that Amit has worked at. So there are different types of nodes like this. Similarly, if we see the relationships, right? So the relationship between Keerti Purswani, who is of the type person, and Amit Kumar, who is of the type person, is that we are married, right? So the relationship is that we are married. Similarly, the relationship of Keerti Purswani with Educosys, which is a company, is that I am the co-founder of Educosys, right? Similarly, Keerti Purswani and AgentStop.ai, again, I am the co-founder of AgentStop.ai. So this is so nice, right? So what did LLM do? LLM basically went through the entire document, understood that these are the nodes or the entities and these are the relationships between these different nodes. So it was as simple as that. Again, I'm repeating, I am using LLM transformer over here, which is provided by the framework LangGraph, LangChain. But we could have also written the entire code ourselves. Like basically we would have to call one LLM and tell in the prompt that this is what I'm looking forward to, give me in this particular structured format. Or I can use a framework like LangChain, LangGraph. Let's also look at the example that they had taken in the documentation. So for this text, this is the nodes and the relationships and the graph that they got. They have also given the visual representation of the graph, okay? So the nodes were like Marie Curie, who was of the type person. So this is Marie Curie. Then Pierre Curie, again of the type person. Here, notice something, that these two persons are in the same color while visualizing the graph, right? So these are the good things when you're using graph databases like Neo4j. So from the visualization itself, you can see that, okay, these are of the similar types. Like University of Paris is of the type organization, right? So University of the Paris is going to be in a different color because it is of the type organization. I think they have not given the entire output over here because other nodes and all the relationships should be there. They have given a subgraph, or I think they have not printed it properly, but you get the point. Even in relationships, you can see that Marie Curie and Pierre Curie, they should be married, right? So there should be a relationship over here called married. But okay, you can see that there are some mistakes in the documentation. Like Marie Curie, if you see with University of Paris, professor is the relationship, which is true. So here this is there, right? But there should be more relationships. Let's concentrate on the example that we have taken and let's try to print a similar graph. And I hope we are able to visualize it like this, right? So there's a very common code that is usually used for visualization. I will be using Pybus, okay, and you can also use this. By the way, the entire code and the notes for all my videos is always available in the description, so you can please check that out. So if you want to run the code as it is like one by one, you can definitely check out the description. Let me just run this. Here I'm doing nothing, I'm just taking out the nodes and the relationships. This is a for loop and I'm just drawing the entire thing. This is a very common code that is usually used, and what is going to happen is that there's going to be a new file that is going to be saved. So as soon as I run this, you can see that there's one HTML file that is created and I should be able to see it over here, right? So that opened in my another Chrome browser. Let me just run it over here. So if I just paste it, here you can see, right? So this is so beautiful. Let's look at it. So you can see that Keerti Purswani and Amit Kumar are people. So they are of the same color. They both are married, and Keerti Purswani and Amit Kumar are co-founders of Educosys. They are co-founders of AgentStop.ai. So here you can see AgentStop.ai. So let's look more. So you can see that these are all the organizations, right? So Amit Kumar, who is my husband, has worked at Siemens, Upstocks, Philips, Adobe, Oracle, and I have worked at Intuit, Tally Solutions, Atlassian, and I am an alumni of an ITC startup, right? So you can see all of this. So this is what I had given in the text, and so what LLM did was LLM was able to identify that these are the major nodes of the entities, and this will be the relationships, and we were able to draw the entire graph using the nodes and the relationships that was extracted out. Next, in the documentation, they have given that we can also define specific types of nodes and relationships for extraction. So suppose instead of this entire graph, if I want to see only a few types of nodes and a few types of relationships, then I can have a filtered LLM transformer that allow only these nodes and allow only these relationships. So let's try that out also. Also, they have clearly given that the graph construction process is non-deterministic since we are using LLM. You might get slightly different results for each execution. See, it really depends on the text that we are giving. Like over here, if you see, I've given a lot of dates as well, right? That when I was born, when did I pass out from NITC, my degree was in what, like electrical and electronics. So when did I start teaching? When did I start working? When did we find Educosys? So it really depends on what is LLM finding more important in the text that you have given, right? So like I had written that Amit teaches C++, but it did not pick all of these little things, right? And it also depends on how clearly what you are mentioning in the text, what are you emphasizing on. So if you clearly mention a few things, it is going to focus on a few things. You can try that out. You can try changing your documents and you can see that the graph is going to change. And I played around this a lot, like before recording the video, and I was seeing that sometimes it was not catching that Amit and I are married, sometimes it was not catching different things. So these things are still in the developing stage, and that is why everyone is talking about it now, right? But again, the point is you can make it better by giving good documents, by giving good prompts, and it is going to become better, and it is becoming better at a really good pace. So that is why it is the talk of the hour, right? Here also, as we were saying in the documentation, like not all the nodes and not all the relationships were mentioned. Like there should have been a married over here when you tried visualizing the graph, right? So little things like this are going to be there because you really do not have full control when you're dealing with LLMs. So that is always a challenge whenever you're dealing with LLMs. There's a lot of unpredictability, but I hope you understand why, because it's about how you are understanding the language, how you're understanding the document. So there's a lot of unpredictability involved that where LLM is going to give more importance to. But all right, now let's try filtering our LLM transformer. So I'm going to copy that. And what nodes should we give? Let's try only for persons and maybe only married. The spouse is also what they have, but let's try married because that is what came in our case. So let's try this out, and we are going to get nodes and relationships again. So in this, let's try running it. So here we got Keerti, Purswani and Amit Kumar. So we did not get all the organizations, the companies, right? And the relationship that we got was married. So there's only one relationship. So this is like a subgraph. We can also visualize it. So the function that I had written, I'm just going to call the same function, and I'm going to pass the graph documents filtered over here. Again, it is going to get saved in our same HTML file. Let me just refresh that. And here you can see it's like the subgraph, right? So like this, play around with it. You can always keep changing the allowed nodes, the allowed relationships. Suppose I also give organization and co-founder, you will be able to see that. If I give organization and employee, then you'll be able to see which all organizations I was employed at. Next in the documentation, let's see what else they have done. Now they are going to be storing to the GraphDB, right? So now to store to the GraphDB, we first need to connect to our graph database, which is Neo4j. So this is the part that we had missed in the starting, right? So we have to create a graph. So, and then in the graph, we will be able to add the graph documents, and the graph is going to be stored in Neo4j, right? So that is what we need to do. So I am just going to go to neo4j.com. And let's go over here and let's start building. Let's sign in with Google. So currently I have no instances. So one instance is free. So I'm going to be getting started with the free instance, and I have to copy this password, right? So this I have to copy only once. I can also download and keep. So I'm just going to add it to my env. I'm going to save it over here, and the instance is getting created. Let's just give it some time. It took some time, but the instance is finally running. This is the ID that got created. So what I did was I copied it. I went to my env, and I can give URI like this. So I just copy pasted the ID over here. Now let's go back to the code and let's continue writing. So if you look at the documentation, the first thing that we have to do is create the graph, and then we'll be able to add, right? So just like this, we'll be just copy pasting, and let's try creating our graph. So I have to create Neo4j graph. So that is why using frameworks is awesome, because they have support for already creating Neo4j graph, right? So it's pretty cool. Here we can pass the URL, username, password, just like this. So let's quickly do that. I have added everything in my env. So I just need to get from my env and I need to pass it. So we just created our graph and we are now ready to add to our graph, right? So this is the graph that we created. So we basically just connected to our Neo4j instance, and the graph documents that we had created, that we need to add to this graph, right? So we first created the graph documents, all of that part is done. We just need to add to our graph now. So I'm just going to copy this and paste it, and here we have to pass graph documents probs, right? So this is what we are passing. Give me one sec. So let's go back here. Let's do for our original graph. So for that, these were the graph documents. I'm just going to add it over here and I'm just going to run it. And now if we go back to our instance and let's connect to it. Here you can see all the nodes that I have. So these are the different nodes. So here you can see Philips, Adobe, Atlassian, Intuit, Tally Solutions, Upstocks, right? So these are the companies that Amit has worked at and I have worked at. So now let's see what are the different nodes. So this was just the company. So right, so the company ones are in peach color. Then institution is only one. There are two persons, Amit Kumar and Keerti Purswani, if you want to see relationship. So there is one relationship of alumnus. Then co-founder, these are the relationships. So we both are co-founders of AgentStop and Educosys. Similarly, employee relationships, married relationship, right? And if you want to see the entire graph, you can see the entire graph as well. And all the queries that I just ran, you will be able to see over here. So this was the query for seeing the married relationship. This was the query for the employee relationship. So this is what we just saw, right? So let me just zoom out. So this was for employee, this was for co-founder. So like this, you can also write your own queries, right? So let me show you that also. Like for company, if you want, you can match like this and you can show, you can also put a limit, right? So if I just copy this query, you can also go through Neo4j queries like separately. And if I just run this, I'll have to remove the colon, and if I run this, you will be able to see the entire graph, right? And you can also zoom in and see. This is pretty nice, right? This is so cool. You can also put your simple filters. If I want to see like this or like this, you can just click on this and put your filters, or you can write your queries over here as well. So we just followed this entire documentation, but if we go back to this how-to guides, and in the use cases here for the graphs, you can see that there are two documentations that are available. So we just followed this. There's one more that is available. So if we see over here, they have given that how you can query as well. So this query is that we just saw, no? The same query, if I just copy this, okay? And if I suppose go back to the documentation, to our code, and if I probably write it like this, that custom query, and maybe I'm going to just put it over here. And let's try running the query. How can we run the query? So if I go back to the documentation, I can just run it like this, graph.query, right? So let's try doing that, graph.query, and we are going to be passing custom query over here. And once I pass this here, you can see there is only NITC because that is the filter that I had added. Suppose I add another query. Suppose we add only this, that I want to see only the persons. So earlier I was seeing only the institutions. Now I am matching only persons, right? So if I do that, I will be able to see Keerti and Amit. So instead of visualizing this like this, you could also run your custom queries in your code itself. So let me just show you this as well. So if I want to see entire thing, you'll be able to see Keerti, employee, founder, married, right? You'll be able to see everything. So this is how you can run the queries. Other than that, in this documentation, they have given how to create custom tools. See, this will be very useful when we talk about GraphRAGs. Now, what are GraphRAGs? In the first documentation also, if you see in the first line itself, they have given the constructed graph can be then used as a knowledge base in a RAG application. See, in the starting also, I told you that a very, very important application of knowledge graphs is basically GraphRAGs, and that is the use case that everyone is talking about. It is very, very relevant, and that is the main use case of knowledge graphs. If you do not know about RAGs, I highly recommend you to watch these two videos. Especially in this video, I have covered end-to-end code also of RAG, and it will be really useful. I highly recommend that you watch it after this video. If you do not know about RAG, let me give you a quick context, and if you know about it, this will be a quick revision for you. See, suppose we are querying our LLM, right? So there's a query from our user, but it is about specific information that is available only in our database. So maybe it is about my products or my courses that our LLM does not know about. So what I can do is, from my database, I can take out the relevant information. Like suppose in the query we are asking about the generative AI course at Educosys, then what we can do is we can fetch out information about the generative AI course from the database and then pass it to our LLM along with the query. Let's see, this is the query that came from the user, and this is the information that you can use to answer the query. So what are we doing? We are retrieving the information from the database, we are augmenting or attaching it to the query, and then passing it to our LLM to be able to answer the query from our user, right? So retrieval augmented generation is called RAG. Now in the first part of the video, we had discussed that using graphs, it is very easy to be able to spot patterns, to be able to get relevant information in a very complex data, right? In real cases, our data is going to be really complex. So that is why for RAG applications, knowledge graphs are really being used. Why? Because the better the retrieval, the better our LLM is going to be at answering the queries, right? In RAG, retrieval itself is a huge part. The more relevant information, the more specific information we can take out from our database, the better we will be able to answer the queries using LLMs, right? So for the retrieval part, what if we use knowledge graphs to store the data and then retrieve the information from that? Then we'll also be able to capture more complex relationships and patterns and all of that, right? So this is where GraphRAG comes into picture. It's a very important application of knowledge graphs, and I plan to cover a dedicated video on GraphRAGs. Let me know if you would be interested. I would like to cover the code as well, and it will be a very interesting video. So if interested, please leave a comment saying GraphRAG, and I would love to create a video of that. And just a quick reminder that this brings us to the end of the video, but it would mean the world to me if you could just leave a comment, share the video with your friends if you found it useful, and please subscribe, guys. I really think I deserve 1 million subscribers. Please do subscribe, share and like. Thank you. See you next time.